Okay, good morning friends. Chapter number 11, Work and Energy. Today we start the example 11.2. Here a porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. We have to calculate the work done by him on the luggage. So here the mass of the luggage, that is 15 kg, and displacement is 1.5 meter. Now as we know that the work done, W is equal to force multiplied by displacement, but F is equal to mg. Force is equal to mass into gravitational acceleration. F is equal to mg. So this is equal to mg multiplied by s. Now mass of luggage is 15 kg multiplied by g value 10 meter per second square, and displacement s equal to 1.5 meter, and multiply it. So 225 kilogram meter per second square into meter. So it is equal to 225, that is SI unit of work, that is Newton meter or Joule. So this is equal to 225 Joule. So work done is 225 Joule. Now next question. First, when do we say that work is done? So work is said to be done when a force acts on an object and the object moves in the direction of force. Second question, write an expression for the work done when a force is acting on an object in the direction of its displacement. So as we know that work done equal to force multiplied by displacement, that is W is equal to F multiplied by S. Next question 3, define 1 joule of work. Here 1 joule of work is said to be done when force of 1 Newton acting on the object displaces it in the direction of force through 1 meter. Again I repeat, 1 joule of work is said to be done when a force of 1 Newton acting on an object displaces it in the direction of force through a 1 meter. Next question, a pair of bullocks exerts a force of 140 Newton on the plow. The field being plowed is 15 meter long. How much work is done in plowing the length of the field? Now here force F is equal to 140 Newton and displacement is 15 meter. Okay, and we have to find out the work. Now as we know that work is equal to force multiplied by displacement. Force is equal to 140 Newton, displacement is 15 meter. So 140 multiplied by 15. So answer will be 2100 Newton meter. Okay, work done by the bullock is 2100 Joule or Newton into meter. Now we discuss the next topic, that is energy. Now life is impossible without energy. Life is impossible without energy. Here the sun is the biggest natural source of energy to us. The sun is the biggest source of energy on the earth. Activity 11.5 we discuss. List the sources of energy. List the sources of energy. So as we know that solar energy, nuclear energy, tidal energy, energy from the interior of the earth, wind energy, energy of flowing water, etc. These are the sources of energy. Next, discuss the sources of energy due to the sun. Now, as we know that the sun is the ultimate source of most of the forms of energy: wind, heat from the interior of the earth, fossil fuel, food prepared by green plants in the process of photosynthesis, etc. So all these are the sources of energy due to the sun. Next question: are there sources of energy which are not due to the sun? Are there sources of energy which are not due to the sun? So for that, energy from nuclear power plant, energy from the nuclear power plant, chemical energy provided by the batteries, hydro energy. Okay, so all these are the sources of energy which are not due to the sun, which are energy from the nuclear power plant, chemical energy provided by the batteries, hydro energy. Okay, all these are the sources of energy which are not due to the sun. Now here next energy. Now let us consider that is one example, that is suppose an object when raised to a certain height and gets the capability to do work. And you must have seen that when a raised hammer falls on a nail placed on a piece of wood, it drives the nail into the wood. Similarly, we have also observed children winding a toy, that is such as toy car, and when the toy is placed on the floor or on the table, it starts moving. Another example, when a balloon is filled with the air and we press it, we notice that there is change in its shape, and as long as we press it gently, it can come back to its original position or the shape. However, if we press the balloon hard, it can even explode, producing a blasting sound. So an object having capability to do work is said to be possesses energy. Okay? An object having a capability to do work is said to possesses energy. Here, an object that possesses energy can exert the force on another object. An object that possesses energy can exert the force on another object. So when this happens, energy transfer from the former to the later. Okay, energy is transferred from the former to the later. Here, any object that possesses energy can do work. Any object can possesses energy can do work, and the energy possessed by an object in terms of its capacity of doing work, and the unit of energy is the joule, 1 joule, that is J. Okay, symbol is capital J. So 1 joule is the energy required to do 1 joule of work, and sometimes a larger unit of energy called kilojoule, that is small k and capital J is used. So 1 kilojoule volt, 1 kilojoule equals to 1000 joule. Okay, again I repeat, that is an object having a capability to do work is said to be possesses energy, and the unit of energy is joule, the same as the unit of work. Okay, and energy is a scalar quantity. Energy is a scalar quantity. Now, forms of energy. We discuss about the forms of energy. The various form of energy, that is mechanical energy, heat energy, chemical energy, electrical energy, light energy. Okay, all these are the forms of energy. Okay, now mechanical energy, that is kinetic and summation of kinetic energy and potential energy. Okay, it's known as the mechanical energy. Kinetic energy, the summation of kinetic energy and potential energy is the mechanical energy. Another energy is heat energy, chemical energy, electrical energy, light energy. Okay, so all these are the forms of energy. Now here think it over, that is, how do you know that some entity is form of energy? So here, if the entity is a form of energy, then it can be transferred into other forms of energy. Okay? If the entity is a form of energy, then it can be transferred into other form of energy.